Welcome friends to SSC CGL Tier 2 level Quick Algebra Problem Solving. This is Atanu Chaudhary of SureSolve. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SSC CGL Tier 2 Solution Set 14 on Algebra 5 from suresolve.com. Let's start solving this set of 5 interesting problems. To evaluate x and y, you have to get the value of x minus y, and together with x plus y, you will get the individual values of x and y. That is easy. Working backwards one stage, to get the value of x minus y, just subtract value of 2xy from x square plus y square and take the square root. So you will end up with the immediate task of finding the value of xy. That is also easy. Square up x plus y and subtract x square plus y square from the result to get x square plus 2xy plus y square minus x square plus y square equal to 16 minus 14 equal to 2. So xy equal to 1. And x minus y whole square equal to 14 minus 2 equal to 12. Or x minus y equal to 2 root 3. As x greater than y, only positive value of x minus y is valid. Adding this value with x plus y equal to 4 and dividing by 2, you get x equal to 2 plus root 3, and subtracting x minus y from x plus y and dividing by 2, you get y equal to 2 minus root 3. Answer is option C, 2 plus root 3 and 2 minus root 3. The problem can be solved easily in mind. Let's solve the next question. You find it infeasible to find the value of a minus b minus c by deductive steps from the given equation. The only possible way to solve the problem should be to transform the given equation to a sum of square expressions equal to 0 and get the values of the three variables directly by principle of zero sum of square expressions. Though you are sure of this possibility, still for checking, you equate 38 with sum of squares of 2, 3 and 5 and get 2 square plus 3 square plus 5 square equal to 4 plus 9 plus 25 equal to 38. Your check is satisfied. 38 will provide then the squares of the 3 second terms of the 3 square expressions. Now rearrange the terms to transform the given expression to a minus 2 whole square plus b plus 3 whole square plus c plus 5 whole square equal to 0. As each of the square expressions must be 0 for the sum to be 0 by principle of zero sum of square expressions, a minus 2 equal to 0 or a equal to 2, b plus 3 equal to 0 or b equal to minus 3 and c plus 5 equal to 0 or c equal to minus 5. So, a minus b minus c equal to 10. Answer is option B, 10. The key concepts and techniques used are pattern discovery that the given equation can be converted to a sum of square expressions equal to 0 and thus get the values of three variables directly from the principle of zero sum of square expressions. Next question now. The obvious method to factorize the given expression is to express it as a suitable quadratic expression in terms of a plus 1 by a or a minus 1 by a. By suitability we mean quadratic expression that can be factorized easily. On further examination the choice becomes clear. The given expression is a square plus 1 by a square minus 13a plus 13 by a plus 34 equal to a minus 1 by a whole square minus 13 times a minus 1 by a plus 36. Equal to a minus 1 by a minus 4 multiplied by a minus 1 by a minus 9. We have used component expression substitution of a minus 1 by a mentally. Answer is option B, a minus 1 by a minus 4 multiplied by a minus 1 by a minus 9. The key concepts and techniques used are abstraction in imagining the target expression as a quadratic expression in a compound variable, identifying the compound variable as a minus 1 by a, and straightforward factorization of a quadratic expression. Let's solve the next question. Following the strategy of denominator simplification, we would first simplify the third denominator using given a plus b plus c equal to 0. You have a plus b plus c equal to 0, or a plus b equal to minus c, or a plus b whole square equal to c square, or a square plus b square minus c square equal to minus 2ab. Similarly, b square plus c square minus a square equal to minus 2bc, and c square plus a square minus b square equal to minus 2ca. Substituting in the given expression, you get 2a square by minus 2bc plus 2b square by minus 2ca plus 2c square by minus 2ab plus 3. Now, we must equalize the denominators to sum up the first three terms. To do this, we use the missing element pattern and simply multiply the numerator and denominator of the first three terms by a, b and c respectively to get minus a cube plus b cube plus c cube divided by abc plus 3. But you know that by 3 variable zero sum principle, if a plus b plus c equal to 0, a cube plus b cube plus c cube will be equal to 3abc. So the final result is minus 3abc by abc plus 3 equal to 0. Answer is option D, 0. The key concepts and techniques used are: first, denominator simplification by using the given zero sum of 3 variables. Next, denominator equalization by missing element pattern. And lastly, using the 3 variable zero sum principle. With these concepts and techniques, the problem could easily be solved in mind. Let's solve the last problem. Examining the given third expression, we identify the key pattern of sum of inverses inherent in it. That is, difference in squares of 2 and root 3 is 1. This results in sum of inverses of variable a free of third. That is, a plus 1 by a equal to 2 plus root 3 plus 1 by 2 plus root 3 equal to 2 plus root 3 plus 2 minus root 3 by rationalization equal to 4. You have to convert the target expression now in terms of this sum of inverses of a. The objective is clear. Discovering the way to do it is quick and easy. Just divide numerator and denominator of the target expression by a cube and get 1 by a cube plus 1 by a cube plus 3. The problem is now transformed to finding the value of a cube plus 1 by a cube when a plus 1 by a equal to 4. Using modified two-factor expanded form of sum of cubes, you get the sum of inverse of cubes as a cube plus 1 by a cube equal to a plus 1 by a multiplied by a plus 1 by a whole square minus 3 equal to 4 times 13 equal to 52. Value of the target expression is then 1 by a cube plus 1 by a cube plus 3 equal to 1 by 55. Answer is option C, 1 by 55. The key concepts and techniques used are forming sum of inverses free of third from the given value of third variable, transformation of target expression in terms of the sum of inverses, and use of two-factor expansion of modified sum of cubes. This problem could also be solved in mind easily. To read the detailed solutions, refer to the corresponding article in our website suresolve.com. Link is given in the description of this video. And please don't forget to subscribe to our channel for latest uploads. Thanks for watching.